Hi everybody, Gary Simmons here for the Game Institute and welcome back to lesson 28 of our Dead Earth game development series. In this lesson we're going to develop the attack state for our AI zombie system, and that's going to see us adding a new trigger to our FPS controller, which I call the melee zone. And that melee zone trigger is going to have a script on it that is going to detect when any zombies enter it, and will then let that zombie know that it's close enough to the player such that if it wants to, it can transition into its attack state and start playing its attack animations. We're also going to do a lot of work in the animator, creating a brand new attack layer that's going to contain lots of different attack animations that will be randomly chosen by our attack state. Before we make a start on that though, I do want to address the replenishment rate of our zombie, because at the moment, if you look in Jill's inspector, we've set her replenish rate to 0.5% per second. It's just too slow. If I press play, so I've paused the video just to wait for Jill to get around here. Oh, also something else I want to address. Look how she goes from this walk animation into the sort of patrolling speed. The transition is not anywhere near gradual enough. She's kind of 1 minute she's walking and then the next minute she's jogging, and I don't like that. But we'll address that too. That's just a slight tweak to the animator. So if I select Jill's AI entity game object while she's feeding and look in her inspector, you can see in the AI zombie state machine component, look how slowly her satisfaction rate is going up. That's because of that replenishment rate. I think if we set that to about 1.5, that seems to be a much quicker replenishment rate. You know what, I might even go for 2 here. Yeah, I'm going to go for 2. So I'm going to stop that, set the replenishment rate to 2, because obviously I made the adjustment in play mode, and that's that fixed. Next thing I want to do is I want to address the depletion rate, because we haven't added the code to our AI zombie state machine class, which actually depletes the satisfaction of the zombie as it walks around the level. So let's add that right now. I keep threatening to do it and then I forget about it. Let's open up our AI zombie state machine class in MonoDevelop. Remember, our AI zombie state machine class is the class that has those 2 serialized fields that we've just seen, the replenishment rate and the depletion rate. So let's now go down to the update function of this class and add just a line of code that's going to reduce the satisfaction factor of our zombie based on the current speed that our zombie is going. So what we'll say is this: satisfaction equals, and what we'll do is we'll wrap this calculation in a mathf max call, okay? Because we never want the result of the calculation we're about to do to ever return a satisfaction value less than 0. So we'll say the maximum between 0. So if what we're about to do now produces a result less than 0, then 0 will be used. And as the second argument, we want our satisfaction to basically be what it is now minus our depletion rate times time.delta time, because our depletion rate is a per second value. So I'll say satisfaction minus, and I'll put this in brackets here, depletion rate times time.delta time. But of course we have to remember, just as we did when we were calculating our replenishment rate, the satisfaction is not in the 0 to 100 range, which is what our depletion rate is essentially describing, a percentage. It's in the 0 to 1 range, so we need to make sure that we divide that depletion rate times by time.delta time by 100 to get it in the correct range for this. So if I save that off now, we should basically see our depletion rate working. We haven't factored in speed yet, we'll do that in a second. So of course I'm going to have to select Zombie Jill and give her a bit of satisfaction to begin with, aren't I? Because we'd set it down to 0. So let's put her satisfaction at about halfway. Press play. As she begins to move, we should start to see our satisfaction drop. And as you can see, it drops very slowly. If you look at this number on the far right side of the satisfaction bar, you can see it's going down. And I think we want something like that. We don't want it to go down too quickly. We want, when a zombie is fed, to go quite a long time without feeding. At least I think. I'm not going to know for sure until I, set up the game and have all the zombies in the level and really start to play test these settings. But I think that seems about right. So what we need to do now is, what we just saw was essentially the lowest depletion rate. So what we need to do now is multiply that by our speed. So obviously if our speed is 2, then the depletion rate will be doubled, which I think is exactly what we want. So let's go back now and just test that. And what I'll do is I'll go down to the patrol state and I'll set a speed up to 2. And the depletion rate should be going down more quickly. Yeah. It works, but I think I want a more dramatic difference in the depletion rate between a walk and a run and a sprint. So I think what I'm going to do is, rather than just multiplying by speed, I'm going to multiply by speed, maybe raised to the power of, I don't know, 3? So I'll say speed to the power of 3. So if the zombie starts really sprinting, then it's going to wear out very, very quickly. Let's see what that looks like. And I've still got the patrol state at speed 2 at the moment, okay? So we should see the satisfaction drop down a lot quicker now. Yeah, there you go. We can physically see that bar moving down now, can't we? But it's not too over the top, is it? So I think we'll go with that. Okay then, so before we dive into the attack state, let's also address that other issue of Zombie Jill's transition from her walking animation to a jogging animation being a little too quick and sudden. And we can do that all from within Jill's animator. So making sure we have OmniZombie Jill's AI entity game object selected, the object with the animator component on it, let's call up Jill's animator window. And the transition that we want to examine is the one that links the zombie walk to the zombie jog. This transition here. And we can see if we press play, we can see it is a very sudden transition. There you go, very sudden. And if we look at the settings for this transition, we can see that it's currently set to have a fixed length transition of 0.25 seconds. Now, one of the things that we could do is turn off fixed duration, and you'll see that the transition duration setting changes from an S, meaning seconds, to a percentage. In other words, a percentage of the entire duration of the zombie walk animation. So what we're saying when we leave it at 0.25 is we want this transition to be the length that is 25% of the length of the walking animation. You'll see that although we might get a little bit of skating, I think it'll be fine. So here we go. You see she really starts to kind of pick up speed gradually. But the problem with using a percentage is that later on we're probably going to want to come back here and duplicate this animator and then swap out the actual animations being used by these states so that we can create different flavors of this animator and have our zombies with different walks, different jogs, different sprints, etc. Now the problem is that if we leave this at a percentage and then we come back later, use a copy of this animator to swap the zombie walk with, let's say, a walk cycle that lasted a minute long, then that transition would take 25 seconds. So I think we really need to stick with the fixed duration. So what I'll do is I will set it to a fixed duration, but maybe we'll move it up to something like 2 seconds. Let's see what that looks like. I'll move the playhead along a little bit so I don't have to wait so long. You will get a little bit of skating when it goes, there you go, that looks right. So you notice you do get a little bit of skating when it goes from the walk into the jog initially, when the speeds of both animations begin to be blended. But I don't think it's going to really matter, and it just looks a lot more organic. So I've left it a fixed duration, and I've set the transition time to 2 seconds. And later on down the line, if we decide to replace this animation with one that's 3 times as long, we're still only going to have a 2-second transition and not a ridiculously long one. So now onwards and upwards with our attack state. Now our attack state is going to need our FPS controller to have a very special trigger on it called a melee trigger. That melee trigger is going to notify any zombies that come in range of it. That means the melee trigger needs to be sensitive to the AI entity trigger layer. Remember, the AI entity trigger layer is the same layer that Zombie Jill's target trigger is on. It's a trigger that is sensitive to AI entities, in other words, Jill's body collider. So we're going to go to our FPS controller and we're going to create a new child object of the FPS controller rig game object. So I'm going to right click and choose create empty. I'm then going to call this melee zone trigger. I'm then going to set the layer of this game object to the AI entity trigger layer. And as this is such an important object to our game, I think I'm going to create a unique tag for it. I don't think I need it yet, but I think we may need it in the future, because if we find that a zombie realizes that it's entered a trigger on an AI entity trigger layer, it may need to know if it's entered a melee trigger or its target trigger. Like I said, I don't think I need it, but there's no harm in having it for now. So I'm going to pull down the tag drop down and I'm going to choose add tag. And I'm going to click the plus sign to add a new slot. And as you can see, it's added tag forward to the end. And I'm going to call this melee zone, like so. Selecting our melee zone trigger again, let's now assign the melee zone tag to that game object. course, it's not a trigger yet. We need to add a collider to it. So let's go over to our FPS controller in the scene and let's add a capsule collider. Now it doesn't really matter how tall it is, so we'll set it to about 2 meters, and I think I probably want this to be something like 0.8. It needs to come out quite away from the player, because remember, this is just the zone at which the zombie feels that it can begin to make attack motions towards the player. Yeah, I think that looks about right. We want the direction to be the y-axis, so we have a height of 2 meters, a radius of 0.8 meters. The capsule is aligned with the y-axis, which is the default, and all that's left to do with this trigger to configure it properly is, of course, set its isTrigger setting to true, like so. So our trigger is set up. So what we need to do now is create a new script that is going to be on our melee zone trigger. And what that melee zone trigger is going to do is when it detects that a zombie has entered it, it's going to contact that zombie's state machine and it's going to let it know that it's in melee range. Now, just to remind you, if we call up our AI state machine script, we added this property down here called in melee range. Remember, this is in the base class script, AI state machine, not AI zombie state machine, because all types of objects, not just zombies, are going to probably want to know when they're in melee range of the player. Think of a dog or a wild boar or something like that. So as we already have this property set up, all our new script has to do is just set this to true when a zombie enters it and set it to false when it exits it. So let's go back to the editor now and let's create a new script, and we'll create this in our AI folder inside our scripts folder. Now you might say, well, hey, isn't this really an FPS controller script? Well, yes and no. It lives on our FPS controller, but of course it is pivotal to the AI system and how it works. So I'm going to right click in my AI folder, choose to create a new C# script, and I'm going to call this AI melee zone. Actually, I'm not going to call it AI melee zone trigger. I'm just going to call it melee zone trigger. It doesn't live on an AI unit. And then with my melee zone trigger game object selected, I'm going to drag and drop my melee zone trigger script onto it like so. Then I'm going to open it up, folks, in MonoDevelop. And as per usual, I'm going to get rid of the boilerplate stuff here, because we don't need a start or an update function in this class. It's going to be a pretty simple one. So this class literally just needs to implement the onTriggerEnter and the onTriggerExit functions so that it can detect if the thing that's entered the trigger is a zombie, and if so, it can contact that zombie state machine and set that in melee range boolean to true. So let's first of all implement the onTriggerEnter function. This, of course, is one of Unity's sort of magic functions. It will be called by Unity and passed a collider. But what we need to do is we need to figure out whether this collider belongs to an AI state machine. And if it does belong to an AI state machine, we need to get a reference to that AI state machine component. Now, this would normally involve a very costly call to Unity's getComponent function that uses reflection to find out if an AI state machine component exists on that object, and if so, returns it. But we don't have to do that, and that's good because we're going to have lots of zombies entering lots of triggers. We're going to be having lots of trigger messages always being generated, and we need, when this happens, to get access to the state machine very, very quickly that this collider belongs to. Unfortunately, you will remember that in our game scene manager, we have this dictionary here. Where is it? There it is. A dictionary of state machines where each of our AI state machines has been registered with the game manager and as its integer key, the collider ID, the instance ID of its collider. And of course, the one thing we do know is the collider in that onTriggerEnter function. So we can get the instance ID of this collider and we can say to the game manager, please give me the AI state machine that is registered with this collider's instance ID. And just to remind you, if we go back to the AI state machine class, because it was a while ago, and scroll down to its awake function, there you can see it says if we have a valid game scene manager, then call it to register AI state machine function, passing in itself as the state machine. And we actually register each of our AI state machines twice with the game manager with different keys. So you can see here we've registered it once with the ID of its actual body collider, and again using the instance ID of its sensor trigger. So if we have either of those colliders, we can very quickly get back a reference to this object and start talking to it. So in our onTriggerEnter function, we can simply create a local variable that I'm going to call machine of type AI state machine, and then we can use the Game Machine Manager's get AI state machine function, passing in the instance ID of that collider. And if a state machine has been registered with that collider's ID, then we're going to get a reference back to that machine, and then we have access to its in melee range boolean. So next up, I just say assuming that it's not some other collider that has got nothing to do with a state machine, use the AI state machine's in melee range property and set it to true. Now you can probably imagine what the on trigger exit function is going to look like, right guys? Exactly the same as this, but setting that value to false. So there you go, on trigger exit, grab the state machine using the collider ID from the game manager using its get AI state machine function, and assuming we get back a valid reference to an AI state machine, set its in melee range boolean property to false. And that is, believe it or not, our melee zone trigger script done. Now of course all that's happening at the moment when a zombie enters this trigger is we're just setting this in melee range boolean to true or false. But we already saw a while ago when we developed our pursuit state that we already have one of our states that is checking this. If I scroll down to the on update function of our pursuit state, you can see that one of the things it says is if our current target type is the player and we are in melee range, then go into attack. So this code that has never been triggered before is going to be triggered now, because we do now have a way of setting that in melee range boolean to true. And of course once we're in the attack state, it's going to be monitoring the in melee range boolean as well, so that if it gets back to false, then we know the player has managed to move away from us a certain amount, such that we're no longer in its melee range, and we should probably then go into pursuit mode and start chasing it again. So a nice easy script. So now you're probably thinking, Gary, let's get on with the attack script. But unfortunately, my friends, we have to do some prep work before we can start writing that code. So designing our attack system is probably going to spread over this lesson and the next, because we're going to be spending most of this lesson now in our animator. And we're going to be creating a brand new animation layer in our animator that I'm going to call the attack layer. And I think probably the best way for me to show you how this is going to work is if I jump over to the current production version of Dead Earth and have a look at how I've set up the attack layer in that project. So have I got my zombie selected? Yes, I have. You'll notice in this animator that I have several layers. Obviously we haven't created the lower body layer, the hit layer, the upper body layer yet. All we've got in our current project is the base layer and the cinematic layer. And of course that cinematic layer has a lot more on it than our current cinematic layer, but we'll get to that. But it's the attack layer I want you to look at. And you can see that the attack layer by default just has an empty state. So it isn't interfering with the base layer or any of the other layers underneath it. And then what we do is we just have a series of different attack animations so that our attack state can generate a random number when it wants to issue an attack and set that as a parameter in our animator. So you'll see that if I call up the parameters window, we have this integer here called attack. And when it's set to 0, nothing is going to happen in this state. But if we set it to 1, then this one will be activated. If we set it to 2, this one will be activated. And of course, these attack animations also need to play out in their entirety. So whereas we normally untick has exit time, with our attack animations, we definitely want them to complete to their end before we go back, because it might be an animation of like a big swipe of a hand or something, or a biting animation. We need that thing not to be interrupted halfway through. So the basic idea is we create a series of animations that can be randomly chosen by its companion state, and we use the attack parameter as a way to communicate from our state to the animator which animation it should play. So if we look at Zombie Attack 2, for example, and the transition into that, we can see that the conditions under which this is executed is if the attack is greater than 6 or if the attack is less than 10. And we're not crawling and we don't have a lot of upper body damage. Now, don't worry about the body damage stuff, we'll deal with that later. We haven't implemented that in our system yet. So the only thing I want you to focus on is where we're comparing the value of our attack parameter, because I didn't want to just have one integer mapped to one animation, because in that case I have no control over making one attack type be more frequent than another. So what I could do, for example, instead, and it's kind of what we're going to do, is we're going to generate a random number between, let's say, 1 and 100, and then we can then decide on these transitions how much of that 100 range should be allocated to the likeliness of that attack animation being activated. So it's basically implementing a probability system within our animations. In our attack state, we will say it's time to attack, generate a random number, stuff it in this attack parameter in the animator, and then create a layer that will override the base layer that will trigger those animations based on our attack integer. But something else I also do in Dead Earth is if I just call up the Layers tab and go down to the attack layer and click on the little settings tab, you can see it's got a mask generated for it. And if I just click on that mask field, so it brings up the mask in the project view and select it, you can see it's called Generic Zombie Upper Body Mask. And if I unfold the humanoid drop down, you can see that the animation layer has a mask that stops it affecting anything beneath the waist. So all of our attacks only manipulate bones above the waist. Now the reason I do this in Dead Earth is because most of the animation assets that I found are in place attacks, which means the zombie stops on the spot and either starts punching, kicking, biting, whatever. Problem is, when the zombie stops on the spot, there's two issues. First of all, it becomes a little bit easier to get away from the zombie, because the player, all he has to do is move back, and because the zombie has to play out its attack animation until the end of its timeline, it means the zombie would just stay there trying to finish off that attack, and you're just walking away blissfully unfrightened by the whole experience. So what we do is we say, well, we want our zombies to still keep navigating towards you, either walking or running towards you while they attack, and that's what that mask allows us to do. It allows the base layer to still operate the legs like it always has done, so it's constantly running into you as it's attacking, and the attack layer just manipulates the top half. And of course the other problem is it was also a little bit finicky with the on-the-spot animations, because we get a trigger registration just as the zombie's collider touches our melee trigger. But of course we've seen before that with root motion, the actual transform of our game object might be animated and might move back. You can imagine, for example, if the zombie leaned back ready to take a huge lunge, his transform would actually move back, that would move his collider back, and then he may no longer be touching our melee trigger, and then drops out of the attack state altogether and finds itself in pursuit state, and then it's constantly going in and out. So we wanted to also get rid of that as well. So this way it's easy. As soon as we're in melee range, we're not even pathfinding anymore. We know we're really close to the player. We point ourselves to look right at him. We start playing our attack animations on the top half of our body, and we make sure that our legs are constantly walking into him by some kind of speed that we can set in the attack state, just so it's almost like the zombie is trying to kind of hold on to the player a little bit. And in fact, I haven't implemented this in Dead Earth yet, but I may also do something like that. I may also say that when the zombies are in melee range, it's almost like they've got hold of the player, and maybe we limit the player from going into run mode or jump, almost like something's got a hold of him and he can only move at, say, crawl speed or something like that. But we'll have to see how it plays, see how balanced it feels when we play the game with all of these things in. Okay, so what we need to do now is go back to our project. We need to create this attack layer, and then we need to start bringing in some of the animations that we wish to use for attacks, and we need to set them up in this way. So in my animator window, making sure, of course, I have Zombie Jill selected just so you've got the right animator open. We're going to bring up the Layers tab, and we're going to click the little plus sign. That's going to create a new layer, and I'm going to call that Attack. And I'm going to move that layer between cinematic and base layer, okay? Because the cinematic layer must override everything. But we do want our attack state to override our base layer. So the next thing that we'll do is we'll create a new avatar mask for our attack layer that masks off the legs so that any animations on this layer only affect the top half. I've already got an avatar masks folder in my project, in my Dead Earth folder. There it is, called Avatar Masks, and we've already got an attack mask from an earlier lesson which I did not know about. How cool is that? Okay, so let's click on that little cog on the attack layer and let's assign our attack mask. And we want to make sure that the weight of the attack layer is set to 1, so any animations on this layer will completely override the bones in the top half of Zombie Jill's skeleton when it's active. And the next thing we'll do is we'll create a new empty state, which will be the default state, so that when we're not attacking, this layer will not do anything and the base layer will be allowed to play unaltered underneath. And just like I did in my cinematic layer, I'm also going to call this empty state. Alright, so I can tell just by looking at it that when this state is active, this layer is doing nothing. So there you go, empty state, no motion field. And what I'm also going to do is go into my avatar masks folder, and that mask that we created a few lessons ago that we're now using as our upper body mask, there's going to be several layers that need this same mask. So I don't want to call it attack mask as that's too specific to just this layer. I'm just going to call it the upper body mask. It's the mask we use when we only want to animate the upper body. Okay then folks, so let's select our attack layer and start finding some attack animations that we can drag into our animator and start to configure. So I'm going to look in my Game Institute folder, and I'm going to look in my Mixamo animations folder first of all, because I think there are some pretty good ones in there. Let me call up the preview window so we can see what's going on. Oh well, we definitely want that one. That is the neck bite. So let's put that one up there. There's a kicking one here. I don't want that. That's not very zombie-like, is it? Yeah, we can have that one. That's called Gillat Zombie Punching. I've got one here just called Zombie Attack. Wowzers. I'm not a big fan of that one. I just can't imagine I can't imagine that looking very good when he stood in front of you. Okay, that's a good one. That's Attack 1. I'll make that one, I think. That one I just showed you. I think I'll make that the default sort of number 1 attack. No, not that one. Attack 1, that one. Dun, dun, dun. Oh yes. What else we got? We've got a headbutt. Do you know what? We could put that in, couldn't we? But I'm not so sure, because I think something like that. Oh, do you know what? We'll put it in anyway, because I think it will at least give us a challenge down the road when it comes to demonstrating how we can make the headbutt dish out damage to the player. So whether we actually want to use it in the end or not, like I said, I think it's going to be a pretty good academic exercise. What else have we got here? I downloaded some of the Mixamo mutant animations as well, didn't I? There's a mutant swipe. Yeah, we could probably put that one in. And let's now go up to the animations I provided you with in the Game Institute attack animations. Got one here like that. Do I want that one? I'm just looking through these a little bit. Oh, look at that one. It's like a triple combo. I think I am going to put that one in, because I think that will be a good demonstration of how we can use animation curves to tell our animator when those hands become hostile and when they don't during the animation. Not a big fan of Attack 3. Looks a little bit lame. That one's quite good. Yeah, we'll make that one a pretty rare attack. I mean, some of these attacks, like cinematically, they look really good, but they also take quite a long time to carry out. And, you know, you kind of think, well, you know, the player's going to have managed to get away from the zombie by the time it actually manages to bring the fist to the player's head. You know, like that one. What I call the wiper blades attack. I suppose we could... No, I'm not going to put that one in there. Not a big fan of that. That one's okay. Is that a double attack or is it a triple attack? Because it also does a base hand. Oh, it's a quadruple attack there. One animation. Not so sure about that. It takes quite a long time to carry out, doesn't it? Well, if we did use an attack like that, I think we'd need to make sure that we didn't have the exit time set, because imagine, for example, after the first swipe, you run away from the player. He's unable to move. Although, having said that, though, we have got the upper body mask, so even if we ran away from the player at this point, the legs would still be chasing after us while he was doing that. What the hell? I'll put it in anyway. Now, obviously, in the Dead Earth production project, I've bought a lot more animations, so I don't have this problem of limited animations, but I wanted to try and, as much as possible, only use the animations that I can provide you with for this demonstration. And I'm just checking the others to make sure there's nothing else there. No, that's all to do with taking damage, isn't it? Yeah. Okay, so we've got all the animations that we can possibly use for now. So let me have a look at these again. So I think that should become our default attack for our zombie, just because it's quick and it's to the point. And another one that should be a very popular one is the neck bite, because in Dead Earth it's actually the neck bite one that's going to actually sort of infect the player, and if the player gets infected, then he's going to have to start taking these sort of pills to stave off the infection. Yeah, that one's not too bad either. And what was the mutant swiping one? Yeah, that's not too bad either. So I'm going to move the headbutt down here. I want to put all the ones that I want to have most frequent chance of being executed together. I think I'll put the headbutt last. I think that's a really weird one. Okay, so what we need to do now, and remember of course in our parameters list that we're going to be having this attack integer set by our attack state. And our attack state every frame is just going to be kind of generating a new random number here. For example, if it's 1, then we're going to go to this attack. This attack is going to play out and then it's going to return back to the empty state. And when it gets back to the empty state, that attack might be set to something else. It might be set to 1 again, in which case we would trigger the attack 1 animation again, or it might be set to one of these other animations. And like I said, rather than just set that integer to 1, 2, 3, 4, 5, 6, 7, 8, I don't want to do that because I want our attack state to be very generic, and another animator that we want to use it with might have only 2 animations or might have 20 animations. And we also want the ability to say, I want these to be executed much more frequently than these ones down the bottom. So like I said a little bit earlier in this lesson, the random number that our attack state is going to generate is actually going to be between 1 and 100. And then using transitions, we can then say, well, if the number's between 1 and 25, then we're going to do this one. If it's between 25 and 35, we're going to do this one. If it's between, you get the idea, right? So let's do our first transition. So I'm going to make a transition from empty state to zombie attack 1. Actually guys, what I'm going to do, I'll pause the video while I do this, okay? But I want to rename all of these states just attack 1, attack 2, attack 3, attack 4. Because although it's really cool that it tells us what type of animation it is, like I said, I'm trying to make a reusable animator here. So in another version of this animator, we may not be having the neck bite motion field being used in this second state. So you should know by now that in order to rename the states, we just select it, and then in the inspector, we just say attack 1, like so. Then select the second one, say attack 2 like so, attack 3, and then I'm going to pause this while I do the rest of them, okay? Okay then, so let's get back to this transition. I think what I'm going to do is I'm going to give attack 1 a 20% probability of being triggered. I'm going to give attack 2 and 3 15% probability each, and I'm going to give attack 4, 5, 6, 7 and 8 10%. That's 10, 20, 30, 40, 50, yeah, 80, and then 20% would be 100. Just checking my math there. Arithmetic is not my strong point. Okay, so let's get back to this transition and give it a 20% probability of being triggered when our attack integer is generated. So first of all, we want to add 2 conditions. Both are going to be checking the value of attack, and we're going to say if attack is greater than 0, okay, so in other words, if attack is 0, then it means we're not in the attack state and we just want to stay in this empty state in the attack layer. But if it's greater than 0 and if it's less than 21, well, there's our 20% probability. Remember, we're generating that attack integer to be a value between 1 and 100. But that's not all we need to do. If you go back to our base layer, you are reminded that we also have this crawling locomotion. Now, we haven't really done much with crawling animations yet, and it doesn't really work right at the moment. We're going to have to go back and flesh that out, which is why we haven't really been testing it that much. But we do have to bear in mind when we make the attack layer that none of these attacks can be triggered when the zombie is crawling. We're going to have to add some other animations to deal with crawling attacks, because if a zombie's crawling and we trigger one of these, well, it's the top half of the body is going to kind of go into a standing up pose. And I don't know what that would look like, but I'm guessing it wouldn't look very good, especially because we've got that layer mask. So I'm also going to put on each of these transitions if crawling equals false, okay? We never want any of these animations to be triggered if crawling is false. And we also want to untick has exit time on all of these. As soon as our zombie chooses to attack, we want to get into that attack animation as soon as possible. So next up, what I'm going to do actually is I'm going to make all the transitions from our empty state to all of my states, and then I will go through them all and set the conditions. Okay, so our second transition should be triggered. Once again, untick has exit time, add those 3 conditions, change the top 2 to attack, and say if attack is greater than 20 and if it's less than 36. Okay, so that's our 15% probability there, and Also, of course, crawling has to be false for this to work. Next up, we said this one is going to have a 15% probability also. So we untick has exit time. We can add those three conditions. We say attack is greater than 35. And attack is smaller than 51. And if crawling equals false. And then these last five are all going to be 10% probability each. So I'm going to click has exit time off. Crawling is going to be set to false on all of them. This needs to be larger than 50, less than 61. Oops, I forgot to change the second condition on attack 3 to less than 51. Did I do that on all of them? No, just attack 3. Okay, so now attack 5, which is between 60 and 70. Once again, unticking has exit time. And saying if attack is greater than 60 and attack is less than 71. And if crawling equals false. Next up is attack 6. Once again, unticking has exit time and saying if attack is greater than 70 and attack is less than 81. Set crawling to false. Untick has exit time. It's a bit repetitive, isn't it? And we'll say if attack is greater than 80 and attack is less than 91. I'm actually getting quite anxious here doing this. And if crawling is false. And as the final transition, we can simply say has exit time is off. We only have to add two conditions. One of them, of course, being crawling equals false. And the other one just being attack is greater than 90, the last 10%, because it's never going to be greater than 100 just by the nature of the way that we generate it. And let me just go through all those and check I've done them right and I've got all the greater than and less than selections made. Okay, that's cool. So the next thing we need to do is create transitions back from our individual states back to our empty state. And each one of these states is going to have two transitions back. When we're in the attack state, we're going to remain in the attack state until we're no longer in the melee trigger. So if we're in the attack state for a period of time, then we're going to be wanting to continually launch attack animations, but we don't want any individual attack animation to be interrupted prematurely. So one of the transitions back has to be simply no conditions, but just when the exit time has been reached. So let's create one of those for each of these states. So as you can see, from attack back to our empty state, no conditions, just has exit time. We're basically saying if you reach the end of your animation, then that you're done. Just go back to empty state. And if attack is still set to non-zero, then one of these other attacks will be triggered instead, or perhaps even the same attack might be triggered again, but just based on how the random number is generated in our attack state. So we need to do that exact same thing now for all of our states. Okay, we just need to create the default transition back, which remember is no conditions and just the exit time having been reached. This was easy enough. But now we want to add another transition to each of these as well, which is if for whatever reason our zombie drops out of the attack state. And we know, for example, that in any other state other than the attack state, such as our pursuit state or our alerted state, one of the things we do on the on-enter state function of that is we set attack back to 0. I go to our alerted state, go down to the on-enter state function. You can see there we are setting the attack type to 0. By the way, attack type is what our state machine calls the property that it sends in as that attack parameter into the animator. If we were attacking and we're in the middle of an attack, or we've just started to launch one of those really long attacks that has like, you know, a 4-hit combo, and then the player runs away from the zombie, we want the zombie to exit the attack animation back into the empty state so that the base layer can take over, which is likely to be running or chasing or whatever. A little bit like in real life. Imagine you're just about to take a swing at somebody and then they run away. You wouldn't continue to follow through with the punch. So in order to do that, every one of our states has to have an additional transition back. And remember, when an animation state has two transitions, we select the transition wire and we see in the inspector the two transitions and we can select them both. So what I'm going to do is I'm going to do that to each of my states first of all, just to save a little bit of time. And of course, at this point, if I didn't do anything else, then each of our animation states would have duplicate transitions coming back. Look, if I select the wire for attack 1, we have two transitions that are exactly the same. They have the has exit time. So what I'll do is on the bottom transition of each one, I will untick has exit time and I will simply say if attack is set back to 0. And we're going to do that on the second transition of all of them. Very important that we untick has exit time, because if we don't do that, then we won't be prematurely able to leave the animation, because it will wait for the animation to complete. Then the transition would kind of be a waste of time anyway, because that's its whole purpose. And I could pause the video, but I'm going to show all of these just so that I don't get accused of skipping on something important. So attack equals 0. And now I'm doing attack 5. Once again, the second transition, untick has exit time, and just say if attack equals 0. 3 more left, and then my anxiety can subside. I hate doing monotonous tasks like this, I really do, especially on video, because I realise how boring this must be, because I'm bored. I am really freaking bored doing this. Equals 0. One more, thank God for that. Untick has exit time. I'm losing the will to live. Attack equals 0, and then I have to do that final pass through them all just to check that I haven't left any has exit time booleans on for that second transition. Okay, so that's our attack layer set up. Like I said, a little bit later on when we start trying to get our crawling animation state to work, we're going to add a few more animations down here that will be what our zombie uses when it wants to attack in a crawling state. I don't currently have any animations in this project to do that, so I'm going to have to hunt around a little bit and see if I can find something for you. Like I said, obviously in the real Dead Earth project, I've got many more animations than this because I've gone on the asset store and I've bought a load, but I'm unable to distribute those to you. Okay then, so with our attack layer now ready to start receiving input, let's go and create our attack state and add it to OmniZombieGill. So I'm going to go into the project window and I'm going to drill down into my scripts folder, into my AI folder, and I'm going to add a new C# script, and I'm going to call this AI zombie state attack 1, like so. And then I'm going to select ZombieGill's AI entity game object and I'm going to add that attack state to it, because I often forget to do that. And then I'm going to open that up in MonoDevelop, folks. So as usual, we remove the start and update functions, the boilerplate stuff, and we make sure that our zombie state attack class is derived from AI zombie state, not from mono behavior. Now this class is only going to need 2 serializable fields, 2 things that show up in the inspector that allow us to configure the speed, which of course is the speed that we wish our zombie to be constantly trying to get to the target at, in other words the player, in this state. And the second is going to be the slurp speed. Both of those properties most of our other states have had. The slurp speed, of course, is the smoothing that we apply as we rotate our zombie on the spot to keep it facing the player. So nothing new there. Next up, we need to create that mandatory override, the getStateType function, and this time we just return, of course, AI stateType.attack. Now let's work on the onEnterState function, something else that we need to override from the base class. We'll put debug log entering attack state. And of course we do that stuff that we've done in all of our other onEnterState functions. We call the base class implementation and check after that that we do have a valid reference to a zombie state machine. And then we configure the state machine. As per usual, we set our nav agent control to true and false, meaning we don't want the nav agent to control rotation, but we do wish it to be responsible for updating the transform of this game object. We set seeking to 0, feeding to false. We set speed to, of course, our inspector specified speed variable, and we set the attack type Remember, we're going into attack now to a random number between 1 and 100. And as you know, that's going to set this parameter here, which is going to trigger one of the animations on this layer. Cool stuff. We'll also create an onExit state function in this class, and we'll just make sure that when we leave this state, attack type is set back to 0 again. Why not? Okay, so let's work on the onUpdate function. Not really anything in here you haven't seen before. Now, in our onUpdate function, the first line we normally put in there is just at the bottom that says return the state that we're currently in. So normally we would expect to see return AI state type.attack here, but you're going to see in a minute when we flesh out the body of this function that we only get to this line if we've actually lost our target and we don't wish to stay in attack mode. So when we have lost our target, imagine for example the player during an attack has managed to very quickly get behind the zombie such that the zombie can't see it anymore. We're going to drop the zombie back down into alert state again, so it stands a good chance of trying to reacquire its target. So I'm going to create a vector3 called target pass and a quaternion called new rotation, just because we're going to need those in a couple of the code blocks that are to follow. And the first thing we have to make sure is, do we still have the visual threat? And this is really important. We don't really want to stay in attack mode if we can't still see the player. Okay, so pretty much everything to do with attack is going to be in this block here. When we're in the attack state, we really don't care about any other threats. We're already trying to get the most high priority threat that there is, so we ignore everything else and we don't do that usual threat assessment. It's basically a case of, if we can see the player, then do the attack stuff, and if we can't see the player, then drop back to alerted so that we can try and reacquire the player. So inside this conditional, if the player is still the visual threat, then we set it as the current target, and then we check to see that we're still in melee range. If we're not in melee range anymore, then we need to drop back into pursuit mode and begin chasing the player again, because it means the player has been able to shake off the zombie and perhaps run away or back away, such that the zombie is no longer close enough to the player that he can start launching his barrage of attacks. So as you can see, we're using the in melee range property of our state machine and simply saying if it's no longer set, if we've left that melee trigger, then drop back into pursuit mode and plot a new course to the player's new position. If that's not the case though, we can see the player and it still is in melee range. So assuming that we're not using root rotation, which we're not going to be for any of our attack animations, we're going to do that rotate the zombie to face the player thing that we've done everywhere else before. We get the position of the zombie's target and we set the Y component of that target to the zombie state machine's Y position, just so that we're essentially doing a 2D rotation here. And then we generate that new quaternion by just saying we want to create a rotation that is going to look from our current position to the target position. And of course we don't just want to assign that straight to the rotation of our zombie state machine, but instead we slurp it over time. As you can see, we use the quaternion slurp function to slurp from our current rotation to this new rotation. That's our desired rotation. How much do we do that by? Well, by time.delta time multiplied by our slurp speed. Next up, if we're attacking the player, then pretty much every frame we just generate that random number between 1 and 100. Now remember, our attack layer has all of its animations to pretty much play out till their exit time unless attack equals 0. So it doesn't matter that in the attack state we're constantly every frame generating a new attack integer, because if we're halfway through the first attack animation, for example, it doesn't matter what number we're generating, this parameter is going to be ignored until this animation is over. Then it transitions back to the empty state, and only then really will that attack parameter have any bearing on what transition gets activated next. So it's just like a dice that's constantly spinning, if you like. Finally, because we can see the player and we're still in melee range and we're still rotating to face him every frame and we're still generating attack integers, we want to stay in attack mode. That's why we haven't got this line here at the bottom, because if we are still attacking, it's all handled in this code block. However, if we get outside this code block, then like I said, it means that the player has somehow managed to get behind the zombie very, very quickly, in which case we pretty much do the same thing again, but we drop into the alerted mode and we just make our zombie immediately face the last position that the player was sighted at, which might just be on the periphery of the zombie's view cone. So we're just saying if we can no longer see the player anymore, just make sure that we face our zombie at the last place we did see the player, drop down into the alerted mode, and then of course that zombie is going to seek left or right and hopefully very quickly acquire the player again, so that the zombie isn't too easy to get away from. So I'm going to go back to the editor now, see if I've got any errors, and I haven't, which is surprising. And what I'm going to do is I'm going to press play, and I'm just going to test it works, and I'm also going to point out a few things that I don't like. As I creep up on our zombie, I think I have her field of view set a little too wide now, because as she sort of starts to seek round, it's almost like she starts to see me before she's actually facing me. You see there, she started running towards me before she could really see me. But you'll notice when she comes up to me now, she is now trying to attack us and do all sorts of things. There she is. She's doing all sorts of combos. And she, you know, when we get out of her melee range, she does go back into pursuit mode. And she does try to get us again. Ooh, she's coming at me again. And you can also see, I think, that the zombie is not really getting close enough to us. So I think what I need to do also, as well as adjust the field of view, I need to bring in the radius of the nav agent, sorry, not the nav agent, the nav obstacle that is on our first person controller. We want to make it a little bit thinner so that it allows the zombie to get closer to us. So the first thing I'm going to do is I'm going to select Joe's AI entity game object, and I'm going to reduce that field of view from 180 to about 120. And I'm going to go down to my first person controller rig, and if I just call up the scene view so we can see it in the scene view, I'm going to bring in that radius to about 0.1 maybe, or is that too thin? Maybe 0.15. You can see now it's a very thin nav obstacle. I'll have to check that I haven't made it too thin. Okay, so let's see if she doesn't pick us up too quickly now. Oh, that's much better. Now she's running at it. And there you go. She's got much closer to us now. That's cool. And there she is biting us, which I know doesn't look that good at the moment. But bear in mind, in the actual game, when she is biting us, we're going to be having all blood squirting up on the screen and all that sort of stuff. So I think it will look fine. Plus, she's a little bit small compared to us at the moment. But she's doing her thing, isn't she? The only thing I don't really like about our pursuit state and our attack state at the moment is that the head isn't really looking at us. So I think we should probably, before we... I think that was the headbutt. Didn't look that great, did it, when we were stood in front of her? Yeah, I think this is going to be okay. I think I could probably take that radius down a little bit more on that nav obstacle, maybe to 0.1. Let's try that. See if it lets her in even closer. And like I said, she is a little bit easy to get away from at the moment, but you know, if you watch The Walking Dead, that's better. She's in closer. You know, they're pretty easy to get away from too, but when we've got lots of zombies, you'll be getting away from one, and what you might not see is that 3 other zombies have come up behind you and started biting you and all that sort of stuff. But you can see all of the different attack animations seem to be working. But we'll probably have to play around with the probabilities a little bit. Yeah, it kind of looks alright to me. Okay, so I'm going to leave the nav obstacle radius at 0.1, and I think the final thing I'm going to do in this lesson is I'm going to have the head looking at the player when the zombie is attacking it, not just in our attack state but also in the pursuit state, which is something we forgot to do in the previous lesson. Now, whenever we've messed around with this before, it's never really looked that good, and the reason being is we just used a set weight, like say for example 0.7. And as soon as it went into the pursuit state or the attack state, we just assigned that weight instantly, and we saw the head snap, because if it was in alerted mode before, and let's just say while it was in alerted mode it was looking away from you, then the minute it transitions into the pursuit state or the attack state, its head just immediately snaps to look at you. And what we need to do is adjust that weight over time once you've entered the state, so that if when the zombie enters the attack state it wasn't looking in our direction, rather than just seeing this sort of head snap as our IK adjustments override the head bone rotation in the animator, we will ramp that weight up over time. And the other thing we'll do as well is we'll make sure that we don't get the zombie's head to look at the player until it's pretty close to looking at the player anyway. So like if the head is almost kind of within a 15-degree angle of where it should be looking at the player's head, then we'll say, well, that's fine. It's almost looking in the right direction. It's rotated around enough. Let's now just take it the rest of the way and make it look at the actual player position. So we're not doing anything too drastic with the head. We're just giving it a little nudge once it's pointing in the right direction. So in order to do that, we're going to need to create some variables. So I'm going to create two serializable fields, both floats. The first one is going to be called look at weight. I've set this to 0.7 by default, where 1 is the maximum and 0 means no weight at all, obviously. I've given it the range attribute, so we'll get that nice little slider bar. And the look at weight is just a way for us to say how strongly we wish to take control of the head of the zombie to make it look at the player. And like I said, 0.7 works pretty well for me. And the next variable is the look at angle threshold. And the bigger we have this, the earlier we will take control of the zombie's head. Like I said, I think we don't really want to take control of it until we're about 15 degrees or less misaligned from looking at the player. And when that's the case, we'll take this over and make sure that we actually look at the player. And we're going to want another variable as well, because our look at weight basically is telling our state this is the weight at which we eventually want to ramp up the weight of the IK override. So we need to have another variable which is kind of like the current look at weight, which is going to start off at 0 when we enter this state and is slowly going to ramp up to the look at weight. And of course, when we come out of attack mode, we'll slowly ramp back down from the look at weight down to 0 again. So I'm going to put this in my private variables block, and I've called it current look at weight. It's set to 0 by default, and I'm also going to set it to 0 in my on enter state function as well. All right, every time we enter this state, we want to set that look at weight to 0 again. So all we have to do now is we have to override that function from the base class called onAnimatorIkUpdated. And if we haven't got a valid reference to a zombie state machine, we'll just return. That's obvious. We can't do anything if we can't talk to the state machine. So the next thing we'll do is we'll measure the angle between the direction our zombie is facing and the vector from the zombie to the target position. In other words, the player. And if it's less than our look at angle threshold, then now is the time to begin taking control of the head, ramping up that current look at weight and using that to influence the head bone of our character. So if that's the case, we'll say we now want to set the look at position of our animator to be the target position, which remember is very often our feet, and we want to add a 1 meter sort of up vector to that. So we look up 1 meter, sort of where the head would be from where the center of our character controller would be. But of course, that's not going to do anything without a weight. If the weight is 0, this will be completely ignored. So what we want to do is we want to slowly lerp the current look at weight towards the ideal look at weight. So we'll say current look at weight equals mathf.lerp, and we're going to do a lerp from our current look at weight to the look at weight that we specify in the inspector, which was 0.7. And of course, time.delta time is used to slowly lerp us towards that weight. Of course, the value is assigned back to current look at weight, which can then simply be set as the look at weight of our animator. And our head will now slowly begin to look towards the player. If the angle is bigger than our look at angle threshold, however, we will start to ramp our current look at weight down by lerping from the current look at weight down to 0. And then, of course, each frame setting that as the current look at weight as well. So as we go into the state, the head will begin to slowly and smoothly rotate around to face the player. But as we leave the attack state, say for example we drop down to the alerted state, we're not just going to see the head snap to the alerted state pose. We're going to see it slowly blend from the looking at the player or looking at the last place the character saw the player to the rotation described by the animation for that bone. And because I think that's going to work pretty nice, I think what I'm going to do is copy that exact system also into my pursuit state. So there is my pursuit state there. I'm going to copy and paste the look at weight and the look at angle threshold, and I'm going to put that in my pursuit state in its serialized field blocks. Actually, I think I'll put it at the top where all of my range attributes are. Why the devil not? And the next thing we need to copy over is our current look at weight there. So I'm going to needs to go in my private variables block there in my pursuit state. Get rid of that redundant comment. And of course, we also want to make sure that current look at weight is set to 0 at the bottom of our pursuits on enter state function as well, don't we? And then finally, we'll copy over the entire on animator IK updated function, because that should just work as is. And we'll stick that at the very bottom of our pursuit class. And hopefully, if I haven't overlooked anything, that should be that done. Okay, let's take this puppy for a test drive and see what happens. There you go, see the head slowly beginning to turn towards us now. And she's kind of looking at us, but she's not looking at us too much. As she slumps forward in her attack state, you know, she's still doing her thing. It's only 0.7 blend, so the animation is still having some control over her head. Yeah, I think that works pretty well. So I think I'm going to leave it there for this lesson, because we've actually done quite a bit. Our attack state isn't finished yet, by the way, although actually that's a bit of a lie. Pretty much the attack state is, but the attack system isn't. There's still a lot more to do. At the moment we've got a zombie that runs up to the character controller and starts playing some animations. But how do we know when our hands and our mouth and our legs are actually kicking or punching the player? How do we do that and apply damage to the player? And that's what we're going to work on in the next lesson, and hopefully also add a little bit of blood splat to our camera lens. So thanks for listening, guys. I will see you next time. Bye bye now.